All right, welcome to today's lesson on outliers. Now, there's not really a whole lot of information to learn about outliers other than we remember that an outlier is a score that is very different from the rest of the data. So I want you to write that into your books and highlight it somehow. It's very important that we know that. It's either much bigger or much smaller, all right? And it can have a significant effect on the average, but has no impact on the median. And this is a reason that we see house prices reported as median house price, because the really expensive houses don't have any effect on the middle number, but they do have an effect on the average house price. So we report median house prices most of the time. So we're going to investigate how to do this and what effect they have. So when we do this, we just have to follow these steps here and answer the questions. We don't have to know anything other than what we just talked about. So it says, the data shows the ages of members of the Binns and Thompson families. So here's the Binns, here's the Thompsons. Calculate the average, answer to one decimal place. So that means it might be 25.7 or something like that. We say, what is the main difference between the two sets of data? So that's directly comparing the two. So we might say, oh, look, they both have 19, then 31, then 21, then 3, then 6, then 14, then 19, then 24. And then the last one are very different. That would be the main difference. All right? It's not talking about something minus something else. We're looking at the two data sets and contrasting them or comparing them, just like we would in English. And then, what effect did the difference identified in part B have on the average? So we might have calculated the average for the first family as 25.7. The average for the second family, because of this extra 91, might have been something like 37 instead of closer to 25. And so we can see here that the effect of that 91 years has increased the average by an awful lot. And it's not accurate because, as we saw, each of these family members is the same age except for these last two people, which means that this average age is skewed by this person's 91 years. And these are not the numbers, hopefully, that will come out of the answers, but it might be something like that. And that's the ideas that we're trying to explore here. All right, so the other questions all do a similar thing. So A says find the median, then find the average. Which measure best describes the prices of houses in Keswick Street? When it says justify, you might say something like, I noticed that the median was closer to most of the houses' prices than the average. And it might happen because of this house, this street has a 1.8 million price tag in it, which will skew all the cheaper, well, relatively cheaper houses by an awful lot. All right, which price is the outlier? Calculate the average of the remaining prices when the outlier is removed. And this is something we frequently do in data sets. We say, oh, that number is clearly too big, let's take it out and ignore it. Okay, and then the question says, is this average closer to the median you found? And if we can get the average closer to the median, that means it's more representative of the data set. All right, so there's three questions there. And then there's some questions here also. It says 12 people work in a small business, calculate the average, calculate the median, which measure is the best reflection of a typical salary. If you wanted to attract new employees, would you advertise the average or the median? Which one would be most beneficial to new employees? Which scores are outliers, so much bigger or much smaller? And then it says calculate the average of the remaining scores if the outliers are removed. So a similar process all the way down the page here, okay? So reminder, we're looking at outliers and their effect on data sets.